In this video, we will do some College Board multiple choice questions about secant, cosecant, and cotangent. This is AP Precalculus topic 3.11. If you appreciate this content, please give it a like. Number 1. Which of the following is the graph of f of x equals 2 times the cosecant of 2 pi over 3x in the xy plane? Cosecant is the reciprocal of the sine function, so the cosecant graph is sort of based on the graph of the sine function. I made a small mistake right here that does not affect the answer, but I want to make the correction. This 2 does not belong in the denominator. 2 times cosecant is equal to 2 times 1 over sine. The 2 does not go to the denominator when I do the reciprocal of cosecant. Again, this mistake does not affect the final answer, but please ignore this mistake when it appears on the screen. We are looking for the graph that has y equals 2 times the sine of 2 pi over 3x, oscillating back and forth between the peaks and valleys of the cosecant function. We have memorized that the parent function y equals sine x looks like this. Focus on the fact that it begins at the origin and then goes up and down and back to the midline. Since y equals 2 times the sine of 2 pi over 3x has no phase shift, there's no value being added or subtracted inside the parentheses, that means that this graph should also start right at the origin and look like this. In option B, the curve oscillating back and forth between the peaks and the valleys does not start at the origin. It starts at a high value. This is a cosine function, not a sine function. So the answer cannot be B. Looking at option A, I want to draw the curve that oscillates back and forth between the peaks and valleys. So I start with a point on the bottom of this valley. Then it's going to hit this intersection of the asymptote and go to the next point at the top of this peak. Okay, so I can repeat the pattern sort of like this. So I can see that this curve that oscillates back and forth between the peaks and valleys looks like this. Again, this curve does not start at the origin. It starts at a high value. This is a cosine function, not a sine function. So the answer cannot be A. Consider option C. Let's draw the curve that oscillates back and forth between the peaks and valleys. It should hit this point, and this point, and also it should equal 0 at the vertical asymptotes. That's why there are vertical asymptotes in these positions. So, sort of connecting the dots, we see the curve would look like this. This is a sine function curve. It starts at the origin, goes up and down and back. So C is a possible candidate. So we won't eliminate that. Let's turn our attention to option D. Again, the curve that oscillates between the peaks and valleys has to hit this point, and this point. And it should also equal 0 at the asymptotes. So this is another curve that is a sine curve. It starts at the origin and goes up and down and back. So we've narrowed it down to either C or D. I'm noticing that options C and D have different periods. Looking at one cycle of the sine function that we just drew, we notice that the period is 6. It goes from 0 to 6. Looking at option D, one cycle of this sine function goes from 0 to 3. So the period here is 3. Let's calculate the period of this sine function and see if it is 3 or 6. So we know that the period of a sine or a cosine function will be 2 pi divided by the b value. In this case, the b value is 2 pi over 3. So when you divide by a fraction, you multiply by the reciprocal. So the period will be given by 2 pi times 3 over 2 pi. Well, the two pi's cancel out. We have one high and one low. Therefore, the period is 3. And therefore, the answer is D. Number 2. Which of the following describes the graph of f of x equals cotangent x? I'm noticing that all of the options have equations that give the infinitely many vertical asymptotes of cotangent x. You should be thinking cotangent is cosine divided by sine. Therefore, cotangent x will have vertical asymptotes wherever the denominator, sine x, is equal to 0. In other words, we can find all of the vertical asymptotes by solving the equation sine x is equal to 0. We solve this equation by asking ourselves the sine of what is equal to 0. On the unit circle, sine is the y value, and y values are equal to 0 here and here. And that's at 0 and pi. Well, wait a minute. We don't want to just make a list. We need the infinitely many vertical asymptotes. So instead, let's start with our one solution, and then realize that we can get to the next solution by adding pi. What about the next solution? Well, the next solution will always be pi away. So by adding pi again, we can always get another solution. Therefore, we can get all of the solutions by adding multiples of pi. That will be pi k, where k is any integer. And we don't really need the 0. So an equation for all of the vertical asymptotes will be x equals pi k, where k is any integer. So we've narrowed it down to either C or D. The expression pi k, where k is any integer, represents the same set of points as pi plus pi k, where k is any integer. For example, if k is 0, 1, and 2, then k times pi will be 0 pi, 1 pi, and 2 pi. When k is negative 1 and negative 2, pi k is negative 2 pi and negative pi. You can get the values of pi plus pi k by starting with the values of pi k and then adding the extra pi. So if I take negative 2 pi and add pi, I get negative pi. If I take negative pi and add pi, I get 0. If I add pi to 0, I get pi. If I add pi to pi, I get 2 pi. Notice that we are getting the same values, just shifted over by 1. Since these values go forever in both directions, both of these sets are the same. So from now on, when you see pi k versus pi plus pi k, just understand that they represent the same set of values. To choose between options C and D, we have to know whether the graph of cotangent x is increasing or decreasing on all intervals of its domain. In previous videos, we learned that the parent function y equals tangent theta is always increasing. We learned that y equals cotangent x is always decreasing. This is a fact I would simply like you to memorize. Since cotangent x is always decreasing, the answer is D. Number 3. Which of the following is the graph of f of x equals cotangent x in the xy plane? Since cotangent x is equal to cosine x divided by sine x, cotangent x will have vertical asymptotes wherever the denominator, sine x, is equal to 0. So there will be vertical asymptotes at x equals 0 and at x equals pi, for example. That's what we see on option A. We see vertical asymptotes at x equals 0 and x equals pi. However, we do not see any vertical asymptotes on any of the other options. So the answer is clearly A. Number 4. The function f is defined by f of x equals the secant of 1/2 times x minus pi over 2, Which of the following describes the domain of f? The domain of a trig function will be all real numbers except for the locations of any vertical asymptotes. So we just need to come up with an expression representing the infinitely many vertical asymptotes of this secant function. We know that secant is the reciprocal of cosine, so the secant function will have vertical asymptotes wherever the denominator, cosine, is equal to 0. In other words, we can find all the vertical asymptotes by solving this equation. First, we solve for 1/2 times x minus pi over 2 by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So the first solution will be pi over 2. We can get to the next solution by adding pi. In fact, we will always get another solution every time we add pi. So we can turn this into an expression for the infinitely many solutions by adding multiples of pi. That's pi k, where k is any integer. Now we just need to solve this equation for x. Multiplying both sides of the equation by 2 gets rid of the 1/2, and we have x minus pi over 2 is equal to, these 2's cancel out, so we just have pi, plus 2 pi k. Now we need to add pi over 2 to both sides of the equation. So I'm doing plus pi over 2 here, and I'm adding pi over 2 over here, but I'm going to combine like terms. So I'm going to wind up adding the pi and the pi over 2. In order to make like denominators, let's think of this pi as 2 pi over 2. So we have x equals 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. So we have x equals 3 pi over 2 plus 2 pi k, where k is any integer. I can already see the equation showing up right here. So the answer is D. Number 5. The function g is given by g of x equals 3 times the cosecant of pi times x plus 2 minus 1. Which of the following describes the range of g? In a previous video, we learned that the range of the parent function cosecant x is -infinity to -1, union 1 to infinity. Focus on the key y values of -1 and +1. Let's see how the transformations that give us the function g of x affect these two key y values. The only transformations that will affect the y values are the ones that occur outside the trig functions, the vertical dilation by a factor of 3 and the vertical translation by -1. So the new y values will be 3y minus 1. 3 times 1 is 3, minus 1 is 2. 3 times -1 is -3, minus 1 is -4. So instead of the range being from -infinity to -1, union 1 to infinity, the new range will be from -infinity to -4, union 2 to infinity. So the answer is D. Number 6. The function f is defined by f of x equals 3 times secant x. The function g is defined by g of x equals 1 over f of x. Which of the following is the graph of g in the xy plane? Since g of x is 1 over f of x and f of x is 3 secant x, then g of x is 1 over 3 secant x. Let's split this apart. So g of x is equal to 1/3 times 1 over secant x. The reciprocal of secant is cosine. So 1 over secant x is cosine x. So except for some undefined values, we are looking for the graph of 1/3 cosine x. Long ago, we learned that the parent function y equals cosine x is at its highest value at x equals 0, and then it falls to its lowest value and rises back to its highest value again. So we are looking for the graph that at x equals 0 is at its highest value. So A is such a graph. At x equals 0, it's at its highest value, and then falls and rises. B is out, because at x equals 0, it's at the midline, not its highest value. Similarly, D is out for the same reason. It starts at 0 and then goes up from there. So D is out. C is still in for one more moment, because it does start at its highest value at x equals 0, and then falls and rises. However, the parent function has an amplitude of 1. It goes from positive 1 to negative 1. This 1/3 in the front is a vertical dilation by a factor of 1/3. So the graph of g of x should have an amplitude of 1/3. It should be up 1/3, a little tiny bit, and then down 1/3. It should not be up 3 and down 3. Alright, it will not have an amplitude of 3. So C is out, and the answer is A. By the way, these open circles are here because secant is undefined wherever cosine is equal to 0. When I say that the reciprocal of secant is cosine, that's not 100% true. Putting 1 over secant does not make the undefined values go away. So 1 over secant is still undefined at these input values. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.